Good afternoon to all and welcome to our third session of Asia Water 2020 Technology Symposium. Before we start, there's a few rules that we have to adhere. All microphone and video of attendees have been muted. If you have any question, please wait for the Q&A session or do list them down at the Q&A box. If there's any internet disruption during this session, kindly be patient and try to sign in again. In this session, we will have Mr. Marcus Chang from Kamstrup to do the presentation. Marcus is an engineer who has been working in the water industry, mostly in water authorities for more than 10 years. He was in software sales as well as being in water meter sales. Marcus joined Kamstrup since September 2019 and is responsible to help customers adopt smart metering technology along with distribution data analytics in the Asia Pacific region. With that, ladies and gentlemen, let's welcome Mr. Marcus Chang to do his presentation. Sir, the floor is yours.
Hello, ladies and gentlemen. Welcome to the Kamstrup part of the seminar. My name is Knut Bonde and I'm the Managing Director of Kamstrup Asia Pacific office in Kuala Lumpur. I'm very pleased to welcome you here, and I'm now going to give you a short introduction to Kamstrup as a company. We have a purpose that we take very seriously. Our purpose is to ensure clean water and energy to a maximum number of people. This we can of course not do on our own, but we do it in close cooperation with utilities, with water utilities. In other words, we help the utilities to do their job in the everyday, to make sure that everybody is ensured clean water and energy. We also have an ambition, and that is to revolutionize the supply of clean water and energy through intelligence. We want to use the data, we want to help utilities use the data of our metering solutions to maximum benefit for both the end customers and also for the utilities in terms of cost down and maximizing revenue. We've got three core business areas at Kamstrup: the heat cooling area, the water area, and the electricity area. Here we speak of smart metering solutions for water, so I will touch briefly on water here. In our water solutions, we of course measure the quantity of water that is used, but we also look at leakages. We have surveillance of leakages. We can help our customers, utilities, to reduce their non-revenue water by giving them an overview of what happens in their systems, improve their operational efficiency, bringing down costs, bringing up revenue, maximize the return on investments. These are some of our main purpose. I will in a moment briefly show our solution. A quick look on our locations. The Kamstrup solutions are basically sold to around 80 countries around the world. We are not global yet, but we are working on it, and we have reached to 80 countries by now. Out of these, we have got our own offices in 23 locations in Europe, in the US, and also here in Asia, where we have got offices in China, India, and in Kuala Lumpur. The Kuala Lumpur office being what we call a regional office for the Asia Pacific region. In all the remaining countries, we have got distributors that we work with. You may, to a high extent, regard Kamstrup as a technology-based and very innovative company. We are altogether around 1,500 people. We put a very strong effort into product development and innovation, and I can mention that more than 300 people, more than 20% of our colleagues, are working on innovation and R&D around the clock. So this really plays a big role for us. This picture shows our solution. If you start at 12 o'clock, we have got the meters, state-of-the-art electronic meters. We add meter reading systems. We add meter data management. We can help managing the data. We can analyze the data through our intelligence software, where we call them water intelligence in the term of water, to help analyze the data and to get a maximum benefit from the data. We also provide hosting and various services to support the operation of the utility. Finally, when we sell our solutions, we can sell them including project management to set everything up, to make it turnkey for you, or we can also sell the projects that you do it yourself. That's various options. But this is how we see our solutions, a total metering solutions, including data analytics and data export also to billing systems and that kind of thing. This was very brief on Kamstrup as a company and our solutions. And I will say thank you for the attention, and I wish you a nice webinar ongoing. Thank you.
Thanks, Knut, for the introduction. So what I'll do is I'll continue on with the slides. We're going to start with talking about smart metering perception today. All right. Now, the dream and objective of smart metering today consists of many intangible benefits. So if you look at intangible benefits, what do I mean? If you look at the list, we have accurate consumption data. We want to detect leakage before, after the meter. We want to increase data resolution so we can do analytics. You know, the dream and the objective is there, and it's the right thing to do. When I say intangible, it does not mean a bad thing. It simply means that we can't measure the benefits upfront. So the approach to this then, as of today, for many utilities, is to try new things. Let us put a module on a mechanical meter, and then we have it transmit data once a day. We have hourly data. Let's see what we do with it. Or maybe I try a low-cost static design. The idea here is to manage cost, right? We want to go to something smart, and in order to pay for itself, it has to be low cost. That is the approach. However, my suggestion is different. We need to have an approach where we let smart metering pay for itself. Instead of limiting us to using low technology approach, like I showed earlier, or less reliable approach, let's use something that is more reliable, however, pay for itself first. So how do we do it? Now, earlier I talked about the intangible benefit. Now let's focus on the tangible benefits first. So meaning, in this case, billing revenue increase, right? If we replace smart meters, we know workforce will be reduced, but that's not our key topic here. We are looking at the meter itself, so billing revenue increase. Under billing revenue increase, we also have two segments here. The first one is to look at non-measurable billing revenue increase. And this has to do with elimination of estimate read, prevention of meter tampering, but we don't know how much of that is happening. So we can't measure it upfront. But what we can measure upfront, here an example, is the replacement of stuck meters, for example. If the meter is clearly stuck, you replace, and then you look at the revenues, you can kind of tell how much revenue you have gained, or badly deteriorated meter, or resizing meters that are wrongly sized. So let's focus ourselves on measurable billing revenue increase. Now, what utilities have been doing to increase or to protect its revenue is to replace the meters. This is done by all utilities. So you have an existing meter, and then as the accuracy falls or the error falls, yeah, there's more error basically, you replace the meter, and then it falls again, and then you replace. So this drop in this increase in error yeah, or drop in efficiency, is mainly because of the deterioration of a mechanical component. As you use it, it fails. That's all mechanical components, not just meters alone, regardless of brand, type, and make of the meter. So where does this information come from? Well, you can search it all over. It's all over on the internet. And in this case, I have two examples. The first example here is the performance analysis of aging single jet water meters. And then there's another article here from Uganda. This is touching on piston meters, the ones that is more frequently used in Malaysia, for example. So the data from this research is as such. The one that is coming from Spain, yeah, the left one. So this is how a mechanical meter performs over time, or in this case, over mileage, not time. What you see here, the key of the graph, yeah, the different color of the different graphs, this is actually the reading on the meter. That is cubic meter, basically. So how much cubic meter has the meter run? So you see, the more the mileage, the worse it becomes. And you can see this is a new meter, 0, yeah, at 0. This is a meter that is just started being used, about 1 to 500 meter cube, yeah, and so on. Yeah, as the mileage increase, the worse it becomes. When I say worse, what do I mean? If you look at the left side of the graph, that's the error. So the percentage error on the meter. And at the very bottom, you see there is about 100%. Negative 100% is hardly reading anything in that flow rate. And when I say flow rate, you see the left and right chart, the x-axis. Yeah, on the left side, you have 15 liters per hour, for example. That's the low flow for this meter. It's an R50 meter. So you can see how the efficiency really impacts the low flow of the meter. So it makes even less sense if you buy a high dynamic ratio mechanical meter. Like if you go for R400 or R800, it hardly makes any sense. And you're lucky if the meter deteriorates like that, you know, that's a normal deterioration process, and that you're lucky. When I say lucky, meaning it could be like that. It could go from a certain percentage all the way down to negative 100. And these are stud meters. And I don't need a research paper to back this up. Basically, you talk to any utilities, they can tell you all about stud meters. And it happens all the time. It has a lot to do with water quality in this case. Now, the idea here is to put in a non-deteriorating meter. If I replace a meter, and if it stays accurate throughout its lifetime, and what's that lifetime? In Kamstrup's case, it will be 16 years. Now, how do I reflect that, you know, comparing with that mechanical meter, for example? When I replace a mechanical meter, the kind of savings I looked at this particular research would be about 5%, based on this particular research, okay? Now, if I can put in a non-deteriorating meter that stays accurate across the board, then what does that mean? It means that I replace upfront with one non-deteriorating meter, and then I do not have to replace any more after that until the non-deteriorating meter dies. And in our case, I mentioned again, it's 16 years. So the savings just on the billing revenue protection side is 15%. Now, we are not jumping, you know, suddenly jumping on the bill and customers going crazy why the bill is so high. It's not. We are simply providing a meter that does not deteriorate. That's all. So it's not going to give you some fictitiously high amount of reading. It's simply protecting your revenue over time, and that you don't have to replace it afterwards. And how do we know this is true? Well, if you look at Kamstrup's experience, you know, application in Europe, many European countries require you to revalidate the meter after a number of years. In this case, it's about 6 to 7 years. Yeah. So there's this particular case whereby we have 1,308 meters being tested from the field. This is from the customer. We are accredited to test meters. And they send it back to us for re-verification as required by law. So we retest it. After those number of years, 96% falls within plus minus 2% error. This is new meter territory, okay? Brand new, better than new in some cases, because our low flow is also plus minus 2. And then about 3.7% is double that, plus minus 4% error, which is acceptable overall. And then if you look at the only 0.3% is out of spec, out of the plus minus 4%. I'm not talking about negative 100% like the mechanical meters, it's just outside the plus minus 4%. So generally we say that our meters will last and be accurate for the whole 16 years of the battery life. We have experience on that. So the enhanced savings, yeah, how the meter pays, how we get a smart meter to pay for itself is that first, put in a smart meter that is robust, that can last the life on field, don't have to replace over time. And then you have this high level of billing revenue protection. So that pays for itself. And then we can have meaningful, tangible, intangible benefits. Yeah, we talked about intangible benefits earlier, detecting leakages, using data for analytics. Now that can also be meaningful. It does not need to be, well, I'm going to put in a meter, gather hourly data, and then let's see what we do with it. I'm going to put into this very robust software I have, and then I'm going to run everything it can do for me. Well, let's be more specific. You know, there are ways we can be more specific. So for example, the meters from Kamstrup have this acoustic logging capability. In this case, you're looking at data from 2 particular locations where the acoustic spikes, yeah? And the customer found the leak and repaired the leak. This is in Vincenter in Denmark. So another case, this is a test from us. We want to know what if there's a leak in the main pipe. So that's the leak in the main pipe. And the houses around it, these are the colors that you see. It's relatively small, I apologize. But those are the readings that you're getting, acoustic readings. The further you're away from the location, the lower the acoustic noise. But it proves that we can hear it back all the way to the main pipe and then up to the neighbor's house. So there is a good and very useful application on smart meters. It has to do more than just sending a meter reading data every hour, you know. And then if we look further, the use of smart meters have many benefits, right? Hidden leakages, we want to find them, under metered metering points, yeah, under metered usage and so on. So how do we address those issues? Well, what we want to advocate also is a smarter use of smart meters. And how do we do that? Example, if we have a DMA where NRW levels are low, we can do monthly acquisition, data resolution can still be monthly. And in this case, what we say is the high resolution switch is turned off. We run things a little bit different, but as usual. For example, when the NRW levels are low, my meter reader will just drive by and read as usual. So I have already eliminated the issue with data accuracy, you know, issues of estimate reads and things like that. Those are all eliminated. And then let's say if you have an issue for this DMA and the NRW level has spiked, yeah, you are collecting data every month and this data is accurate, it's very timely data you use to measure NRW, and that NRW spiked to 15%. So you can continue your monthly acquisition of data, but you want it hourly now. You want hourly of data resolution, meaning if I go there, I have 2 months of hourly data I can retrieve from the meter. Basically, the meter is a logger in this case. So I switch on my high resolution, but the way I do it is my meter reader now will go to the site and extract this data from the meter, meter by meter, right? And I can use all this data. Maybe before my meter reader even extract the 2 months of hourly data, maybe what they can do is go out and install pressure loggers across the DMA, because when I combine pressure logging data and flow data, hydraulic models today can detect possible location of leakage quite accurately. Yeah, it balances the two information to find out where there are possible leakages. And then I can send my non-revenue water team to go have a look. But think about it. The process that I have just mentioned, we can elevate this whole process into the meter reader. No more human resource issues of firing people, by the masses. It is not socially, it is not good for the utility. And from a human resource perspective, it is also expensive. So let's retrain meter readers. Let's have them drive by and read those meters every month. And then when there's an issue, let's empower the meter readers to become owners of the DMA. Let's have them go out to site and extract those hourly data, requests for data loggers, install them because they have the extra time now. Install them, collect the data, collect the hourly data, send them to the hydraulic modeling team for analysis, and then bring that analysis to the non-revenue water team for site verification and then a repair. And then a meter reader is now what we call a non-revenue water technician, can then be compensated for their performances. So these are all KPIs now based on non-revenue water. So let's elevate people within the utility. Let's not get too deep into how can I extract hourly data from my meter from a very blind and very crude approach. Let's look at what we can do to maximize what we currently have and let smart meters be smart, not try to make a dumb meter smart instead, because that can be very costly and it doesn't get us anywhere. And then if we look at the kind of analytics we can do, like for example here from Kamstrup, from analyzing the district, detecting leakage, recording incidents of where problems have occurred to find a trend in those incidents, many things can be done. And if there's any question, please reach out to us from Kamstrup. This is our message. It is all about having a financial, sustainable approach to smart metering, and then have a smart way to roll out real smart meters. Thank you very much for your time, and I hope you enjoy the rest of the event.
Ladies and gentlemen, we have come to the Q&A session. If you have any question, please click on the hand raise function and the organizer will unmute you, or you can list your question down on our Q&A chat box. Please make sure to introduce yourself and which company are you from, followed up with your question.
So Shima, there seems to be no questions, yeah?
Yeah, it looks like there's no question from the attendees. Okay, we have come to the end of our second session today. We hope that with today's session, okay, so if you have any question or inquiry, please visit Kamstrup virtual booth in our virtual exhibition hall. That's all from us. Once again, thank you and please stay safe all the time.